Yeah, hi everyone. So, am I audible?
Yes.
Okay, thanks. So today is the doubt clearing session we are taking for the OPP exam. So already 250 have already give the OPP exam on the 24th July. Uh, so uh, so if you have any query, if you have any topics you want to discuss, you can tell me. Any doubt? Yeah. So Sridhar, Pranav, yeah, Akash, Shrestha, and Aspraja. So if you have any doubt, you can ask, or you can discuss.
There is no specific doubt. So
Okay.
any guidelines or something that it is. If you give me
Yeah,
some
actually, I got the
inputs, then
some post on the discourse where some students are saying that they want some session to discuss some doubt. So yeah, because of that, we are conducting this session. For guidelines, basically for OPP exam. So this OPP exam cannot be revised all these things in the one day or in one session. So definitely you should, if you have completed all the graded assignments by yourself, so definitely the OPP exam will be easy for you. So OPP exam level is not too much difficult. If we compare the graded assignment, so compared to the graded assignment, the level of the question is low. We say that. So if your concept is clear, so I'm not saying that you need more practice. You have to complete it all the problems of live coding practice and graded assignments. If your all the concepts are clear, basically the questions in the OPP is based on the concept or logical things. No need to remember any code directly, or not. No need to remember any big code. Okay, so concept based things like a graph thing. So you should know about this algorithms, Prim's algorithm, Digest algorithms, Kruskal algorithm. You should know about the concept of these algorithms. If you know the concept of these algorithms, you can write the code for that also in the OPP exam if any question is comes in the OPP exam. So the level is easy compared to the all your assignments, graded assignment. So uh, your concepts are clear, then it will be easy.
Okay.
So one thing, so many students are trying to learn the GRPAs, PPAs, and live coding question. So that is also not work, because every problem contains the own concept, own logic to solve. Okay, so if you're trying to learn all the questions, definitely you will forget all the code in the exam. So OPP exam is basically check the logical thinking ability. If you know the concept, how you can apply the concept in the problems, this type of things. Like if you know the sorting algorithms, if any person is required the sorting things, so you should know the sorting algorithm. Same for the searching algorithms. Same for the binary search algorithms. So if any question required some complexity of log n things, log n based complexity. So I think I have already given one question in mock question based on the binary search. Okay, in that question, the problem statement is saying that your output should become in the log n times. So definitely log n time is coming in the questions. So you should know about some good algorithm for searching. So definitely the binary search is provide the log n things. So you can think about the binary search. Similarly, so graph based problems, first identified the first check the problems, what the problem is giving in the input and what they are required to in the output. So according to that you can decide that what algorithm you can use, which you have learned in the graphs week 4 and 5. So that's things are required, concepts are required. Remembering of the person is that not work, that will not work in the OPP if you are directly learning the person. Okay, so you have to think the logic to solve at the same time during the OPP. Okay, so just revise the concept of, or just revise the concept of algorithms. Just see the before the OPP exams, just see all the algorithms which are you have learned in the course. This very important algorithms. So that is more useful. Yeah. So now, if you have any doubt and query, you can ask now.
Sir, I have one general doubt also.
Yeah, I've seen.
So basically, when it comes to the question from week 1 to 9, like week 1 to 8, and even 10 also, that's completely fine. But when it comes to dynamic programming questions, they are at all different. Means every question require different kind of logic, and like like it is covered in only one week. So and it's a vast concept. So like
Yeah.
basically,
So if any question comes based on the dynamic programming, that will be the same same level of you which you have learned in the beat. If any question comes in the OPP.
okay, it is based on the same concept.
Yeah, same concept of similarity level of the difficulty level of the week, your week 9. Dynamic
Okay,
programming week 9.
because setting the base case take lot of time, and
Yes,
also
I know that. I know that this thing. So every dynamic programming problems contains your own logic to divide into the base case and this type of things. So this things have take some time to figure out how you can divide the problem into a sub problem, and how you can start to solve the problem from the sub problem. So these type of things takes time for the new dynamic programming problems. So if any question comes in OPP based on the dynamic programming, so that question will be the same level of the week 9 questions.
okay,
So you have already seen this type of question.
fine.
We are not giving any difficult type of or competition type question in the OPP exam, because we know the constraint. You have only 2 hours and you have 4 questions.
And if we talk about the complexity level, like will it be same like what happened in like 24th of July, or it will be more like
What question comes in the
no sir, I don't know the questions, but I know like somewhat what is the type of question was there. Exact
So
question I don't know.
type of person will be type of person means the level of the question will be same as the mock questions.
Okay,
Okay, no, I'm not saying the type of person, because the concept can be changed, topic can be changed for the questions, but the level of the question will be same as the mock papers.
fine.
Okay, so there are 4 questions, and one question contains the 20 marks, which is the easy level question. So if you the logical based question, maybe if you find out the logic for that, you can complete in 10 to maximum 10 minutes is required for the first question. Apart from that, 3 questions are coming from the medium level type question, not the easy, medium level type. So you can save some time of in the first problem, but you can give this save time into the another problems. So compared to the last term we have only 1.5 hour, and the total problems are 4. And in the last term also, the problem levels of the problem was higher compared to this term. So I think uh, you should give more. You should get more marks compared to the last term students.
Okay, so this time level wise, you have set the complexity less, right?
Yeah.
Okay,
So complexity is less and time is more. You are getting more benefits compared to the previous term.
fine.
Yeah. So, but don't think about that. This is hard. This will be hard. we are not giving the completion type of questions. Maybe some story can be there in the problem statement, but the solution will be based on the same concept which you have learned in the course. Okay, so in some story can be available in the problem statement, so you can figure out what the algorithms you required to solve that problem. So difficulty level is not too much. Just go and try to solve all 4 problems. Okay.
The biggest issue was dynamic programming only, nothing like week 1 to 5 and 6, like all other weeks are kind of solvable. But dynamic programming like took a lot of time.
Dynamic, if you are facing difficulty in dynamic programming, you can solve that problem using the recursive approach also. So you can solve any problem with the recursive approach. It will take more time, but you can solve that by that approach also.
Okay.
So dynamic programming based problem, we not ask the complexity things. So any other query from any specific doubt?
So in code wise, if I ask the doubt, I have doubt in PPA 4 of week 4, PPA 2 of week 4. So I'm not able. Yeah, I'm not able.
It's the same doubt. Same doubt.
Okay, PPA 4 week 4.
No, sir. PPA 2 week 4.
Okay, PPA 2 week 4.
Yeah.
Okay, one second. I'm sharing my screen. My screen is visible.
Yes, sir.
Okay. Week 4 PPA 2. Find all paths. This one?
Yes, sir.
I will search it. So have you checked the solution for that?
Yes, sir. So that is recursive. Can't we do it iterative approach?
Iterative
that has
approach
two
is yeah, I know. I remembering this
And sir, in the solution, it is giving a queue, but we are not using the queue anywhere.
Okay, that things can be possible at the time of writing the solution. So maybe some part we have removed if we are not using. So that's happened everywhere. So ignore that part if you are not using anywhere. So ignore that part. Maybe initial we have used somewhere, but after that we removed that part. Okay, I'm coming to the solution.
So before like giving the solution, can you also discuss the approach how to solve it?
Okay. So actually, approach can be more than one. So maybe approach you can solve the same problem with the different approach. So in the solution, I'm opening the solution. 1 second. Yeah, this one. You find all paths. So here, are you talking about this queue in
Yes,
solution
sir.
code?
Yes, sir.
Okay, so from collection import DQ. Okay, so in after that, I think we have import this queue directly. So because of that, we are not using this my queue. So DQ, I think it is used anywhere.
No, sir.
DQ is also not used.
No, sir.
Okay, then second.
Sir, I looked for the codes on other sites as well, but everywhere I was seeing like node graph. They are making first graph, then doing all these things. So that gets confused because sir has taught in lectures with that we are given a graph, but they are making the graph first, then using that.
No. So input type can be anything. So here sample input we are giving like this, the vertices number of we are giving, and G list. So adjacency list we are giving. Okay, so you can use directly this adjacency list. This is also representing a graph, and a source and destination vertices are given. So you can solve any. You can use anything. You can make the adjacency matrix using this adjacency list. If you want adjacency matrix form of the graph, you can convert it. So that's the things can be different on the other sides. Maybe they are using the adjacency matrix for the graph. So here the problem, here we are giving the adjacency list. So you can change these things by yourself. So in code DQ, I think not used. Okay. The suffix is also given. Okay. So this actually given as a helper function. If you need, you can use. If you have no needs, you can no required to use. So this is given as a helper function in the code. This is the same code. What is expected to the level of the same? Okay, arranged agent. Seeing the same person. Solution. This is function arrange. Where is the arrange? Oh, okay, arrange agent. This part is given, yeah. Yeah, so this part is not used anywhere, so you can ignore that part. So which the part is used is this that part. This find all path, and there is this another part. Yeah, so in this solution we are using recursive approach to solve, like the DFS approach. We are moving to the all nodes and checking that our path is completed or not, from source to destination. If you see this code, okay, so first check this find all path recursive. This is approach given. You got it, the idea of this approach, how we are solving using this
Yes,
approach?
yes, sir. But how can we do it iteratively? Because I was trying iterative approach, then I saw the solution, but I was not able to do iteratively.
Okay, then you are saying that if we can convert this in the iterative approach.
Yes.
Can you discuss this approach also once?
Okay. So find all path recursive vertices. We are getting all these things. So what is the required function name in the question is find all path. Okay. What is a GD source definition? So this is the main function. Okay. So this is the main function we are creating. Here we are creating all path list that we contain the all paths are which are possible and which are unique. And here we are just also creating another list which we will use to pass inside the function in our next recursive call. And this is a dictionary which we have created if our node is visited or not. Okay, so visited. Here we are mentioning for all nodes are not visited as a false here. So here we are creating one dictionary, and we are assigning a value as a false inside it. After that, we are calling this recursive function find all path recursive, and we are passing this all information vertices, glist, source, destination, and apart from that, we are also passing this visited and path and all path. Okay, so how we are using this visited or path, all path information in our recursive call. So if you come in the recursive call, so you can see here visited source equal to true. Okay, so we are coming from here. Okay, the I have called find path recursive vertices, source destination. Okay. So here we are taking this source as a SRC, destination we are taking as a DEST, and this is also visited path and all path. This list and dictionary we are using as the same name. So we are starting from the source node. Okay, so we will just mention that visited SRC equal to true. Okay, that means we have started from the source node. After that, path dot append SRC. This is the here we are creating a path information which we have taken as a list from the previous function, and so here we are adding this SRC into a path. After that, we are checking that SRC equal to DEST. So here actually we are calling this function recursively. So at every time, so I think we get explaining this with the graph in the notepad one second. So this is a graph, and if you solve this using that approach, what we are doing, we are starting from that node. This is a source node. Okay, and I think for example we want to try to solution for 1 to 2. Okay, so this is the solution for 1 to 2. Source 1 and 2. So SRC equal to 1 and DEST equal to 2. And we want to find out all the shortest path. Okay. So we have one list PATH and one more list we have with the path list. So we have one list all path, and after when we are calling at this position, so initially we have we call from this first things. So vertices, we have all the list of vertices. This is the adjacency list. This is the one value if we are solving the problem from 1 to 2. Okay, so 1 to 2, this value is 1, this is 2, and this is the visited word dictionary which we have created as a false by default all for all vertices, and this is empty list initially. Okay, so by the first call, this find all path recursive, we will set that visited source equal to true, and we will append the one value in a path. Okay, so this path where we will append that this one. Okay, after that we will check that SRC equal to DEST. So in the first case, this condition is not true. Then we will move to the next steps for E in G list SRC. Okay, so we will check that what are the adjacent of SRC. So initial stage, what are the adjacent of SRC? 4 and 3. So that means we can move from 1 to 4 and we can move to 1 to 3. Okay, so now we will call, if you check that if not visited, okay, for E in G list, if not visited, that means if the adjacent node is not visited, that means the value is false. We will call the same algorithm recursively, and at that time we will change the source vertices. We are changing the source vertices E. Apart from that, we are passing the same value. So DEST is the same, visited the same dictionary we are passing path, and this thing we are passing. So in the next call, for example, if we are selecting this adjacent, so we are just assuming that now this is a source. Okay, and this function will call again, and is in the next call the source will be 4. Okay, so next call source will be 4. Okay, now we will check that we will mark that this is this node have visited. So we have marked that this is visited. Now we have marked this is visited. Now we will check that this is a destination node or not. So no, and before that we will also add into our path. So like this will become 1 2. Okay, so sorry, 1 4. In the recursive call, we are just adding this path value 1 4 in the recursive call, and same things, this is not a destination. If you see this these things, this is not a so 4 is not a destination because destination is a 2. So same things, now we will check for the same for the 4 node, and we will check what are the adjacent of 4. So adjacent of 4 is once again 7 and 6. 7 and 6. Okay, so 7 and 6. Okay, so recursively this is happening by the recursive call. Okay, so we have just jumped to from 1 to 4, and by the recursive call now we are moving, we are calling again on the 7th node, 7th vertex. Now we will mark as a T, true visited, and we will check that this is a destination node or not. So no, and also we are adding this in our path. Okay, so path, so this is 7. Okay, now we will check that this is not a destination. Then we once again we will check what are the adjacent of this 7 and which is not visited. So the adjacent of 7 is 5. Okay, only 5. Yes, now we will recursively call again on that this on this node 5. So we will mark that is it true. Okay, and after that we will also add into our path list. So this will become like this 5, and this is also not a destination node. Okay, skip that part. We will check again what are the adjacent of 5. So 5 adjacent is 6 and 4 also, but 4 we have already traversed. This we have already make true, so we will not traverse again this part, so we will skip that. And 5 to 6, yeah, we have moved from here, so we will add this in our path. So 1 4 7 5 6. Okay, so from here this is also not a destination. Now we will check for the 6, and the adjacent of 6 is 2. Okay, so in that case, when we have reached at the 2, so we will add this 2 in our path, and we will check that this is a destination node. Yes, in that case, what we have got in the path list 1 4 7 5 6 2. Okay, so we have found that our in the recursive call, so we have called recursively from here from 5 to 6, then 6 to 2, and at this place so this 2 have become the equal to the destination. So in that case, this condition become true. SRC equal to DEST. In this recursive call, we got this SRC2, and this SRC2 will become equal to destination DEST. And in that case, we will append this path. We will append this path into our final resultant list path, all path. Okay, so we will append this complete path into our all path list. So what is the name? All path. Yes. So all path. We will append this answer. This is the one path. Okay, so 1, 4, 7, 5, 6, 2. This one path have added by using this recursive call, one recursive call. Okay, so after that, this part have been completed. So there is no recursive call when we got the same SRC equal to DEST. So in that condition, there is no recursive call. Okay, so apart from that, there is another part we have to call recursively. So for we have to reach back, and we will come back to the 4, and there is another possible adjacent for 4 is 6. Okay, so we will check for that. Till now for this time. So what value was in our path list is, so till that position, path list will be 1, 4. Okay, now we are moving here 6 and 1, 4, 6, and what are the next adjacent of 6 is 2. Okay, when we are calling the recursively this function on the 6, we will check that this is a destination, no, and we will add this 6 into our path list 6, and we will just check, what are the adjacent of 6 is 2, and we will call again the same function, and we will check for that. Now
how you reach back to 4?
So once if one part have been completed, so we will this recursive call will come back on the second call, second steps.
So where this was handled in the code?
Yeah, this is the loop now. So here, if you see this loop, if you are finding 2 adjacent at this position, so this is for E in G list. This E is containing the adjacent node. Okay, so for example, if we are getting E in so in is this position, we are getting the 2 adjacent for the 4, 7 and 6. So for the 7, we are calling recursively. For the 7. So first we will read 7 from this adjacent list, and for this 7 we are calling this function recursively.
Okay.
So first we will complete this path. After that, we will come back and we will complete the second loop. So this will be the second adjacent.
What about these things like the nodes which are setting visited true? How, like initially they were setting true, like when you are reaching from 1 to 4 initial path, you have set some vertices as true.
Yeah, false.
No, initially you set them false, but while transversing that path, you have set some nodes as true. No.
Yes.
Initially, like 1, 4, 7, something like that. Now, when you come back to 4, if 6 is already visited, then it won't go there, right?
Okay, 1 second. So in that case, state. That means you are saying that when we are coming back and we will check for the 6, at that time the 6 have already been visited.
6 is already visited in the first path. Now you are going through 6 again through 4.
1 second, just a copy. Visited. Yesterday we are passing the same things. Not wasted.
Sir, after the loop, we are changing visited source to false in the last path dot pop and visited source to
Uh,
false.
okay. That line we have forgotten. Sorry. So this part we are doing for that. Okay, we are removing the path after this call is completed. So we are removing the path and we are also making the SRC equal to false.
Can you show how it is working? Like,
so it is working like this when the call is completed.
yeah.
Okay. So we find out so we will return back on the back call, and during the return of the call, we will just mark the false things for each node source.
Sir, how is it getting marked and written?
No. So if you are calling these things, so SRC is 2. When we have found one path, okay, so we have found one path completely. So in that case, we are not calling this again. And SRC, okay, so 2.
Sir, if I'm not wrong, SRC is the one source which you are passing in the function call,
Yes.
right? So that is
Yes.
in this case is if not I'm not wrong, that is 1.
In the first path.
Yeah.
No. So this value is becoming changed for the every call. Here we
I
are
don't.
passing E.
You are changing the source over there while making the recursive call, right? You are changing the source, but you are not
Yes.
changing the value SRC.
SRC.
Yeah.
No, but when we are passing this E value as we are calling this function. So this will E value become a SRC, no?
Okay.
Okay, if we passing here 2, so here our SRC will become 2 for the next call.
Okay.
Okay, so here we will check for the 2 equal to destination 2 or not. We are not changing this TEST, but every time when we are passing the different value for this SRC E, okay, in the recursive call E, so this SRC value will become changed.
Okay.
Okay.
So why are you doing why are we are doing this path.pop?
Yeah, that's things we are removing the path from our list. So for example, we have found one path completely. So in the first case, we have found one path. So after completion of this process, we will remove this path. We will just what is this pop? Okay, path.pop. Okay. And so during the recursive, so we are coming from so every time when we are calling recursively, so we are going from 4 to 7, 7 to 5, 5 to 6, and 6 to 2. And when we have completed our recursive call, so we will return back to the previous stage. At that time, we will just remove this 2 from our path list, because we will find out the second path. We have already add this path in our final result. After that, when we are moving back for the second recursive path call, so from 2 to 6, we will remove this 2 from the path list, and we are also making the value for this 2 as a false in the last 2 line. So path.pop, we are removing the vertex from the path, and we are also making the visited value as a false.
So in the first example, like in the first path which you have created, till how many vertex I will remove and
yeah, so just come back to in the back side. So where you are just moving back, okay. So you will remove 2, and you will also make this as a false.
okay.
Same times you will there is no path from there from 6, okay. So there is only one path from the 6, so you will move to the 5 back, okay. And at the time you will remove 6 and you will mark as a false. Same times you will move back to the 7, Okay, you will remove 5 from the path and you will make as it false 5. Same times you will back to here and you will make this false 7 and remove from this 7 from the list. And after that you have reached at the 4. So there is one another path possible from the 4.
Okay, now
Okay,
got it.
this is the second loop for the 4. Okay, this so here we are reading we are using this for loop e value. So one value we have completed. Now we will run this for loop second time for the second adjacent. Now we will check for the 6. Okay, so we have marked this 6 as a false again, and now our path contain only 1 and 4. We have removed all the value from this path. Now we will move back to the call second for the second adjacent. Now we will 4 to 6. Now we will check for the 6 and we will make as it true, and we will add in our path 6, and we will so this 6 is not equivalent to the destination value. So we will check for the next adjacent of the 6. That means we are calling recursively again for the adjacent. So this 2 is the adjacent of 6. So that means we will add this 2 in our path, and we will check that this 2 is equal to our destination. Yes. Now we got one more path. Okay, 5 1 4 6 2. Same things we will append in our path list 1 4 6 2. After that we will come back. So same things we will remove from our path. We will remove this 6 from our path, and we will remove this 4 from our path. Now the second path are possible from 1 now. Okay, we have removed all these things, and we have also marked that this vertex as a false. Now once again we will check for the second adjacent of 1. So this is now 3. So now we will just check for the this is 1. Now next path is 3. So for 3, so this is not equivalent to the destination. We will check for the next adjacent. So 3 to 6. So there is only one adjacent for the 3. So this is 6. Okay. Now this is also not equivalent to destination. We will check for the next adjacent. So this is 2. Okay, we got new path. So we will also add this. So this value will come in our path list. So 1 3 6 2. Now we will add this path in our original path list. This one. Okay, so this one 1 3 6 2. After that we will return back. So we will return back 6 3 2. So I think there is no other paths are possible for that. We have completed all possible calls. Okay. So this is one possibility 1 4 7 5 6 2. There is one another things, these things, and this is the third one. So all path value we have found using the recursive call. So this is actually recursive things. You have to imagination how we are moving from one vertex to another vertex recursively, and how during the return time how we can clear our path list and to check again. So this is the recursive part this code is doing. So you can actually you can make the iterative code also, but you have to find out the logic how you can convert this into a iterative call. Iterative code. So that will be some difficult things. So for example, one famous problem, Tower of Hanoi. If you know that this problem, Tower of Hanoi is a smaller game. Okay. So there is a 3 rod ABC. Okay, so we have 3 disks with a different size, and we want to shift these 3 disks in the A to C completely. All 3 disks we want to move from A to C. Okay, and there is one there are 2 rules. We can move only one disk at a time, and the second rule is we cannot put a smaller disk on the top of sorry, we cannot put a bigger disk on the top of the smaller disk. So with these two conditions, we have to shift this all disk into in our C rod. So what are the steps is required? So this type of problem you can easily solve using the recursive approach in the only 3 or 4 steps. On the code for this tower of noise only contains the 4 lines using the recursive approach. But if you want to try to solve this using the iterative, that will become difficult. So here we are solving this all path things recursively with a smaller code. But we can also find out the all paths using the different approach. So you can try these things with some algorithms like DFS or BFS or iterative code. You can also make. You have to figure out the logic first for the iterative solution.
So if we are asked to find the shortest path, and we use this approach and get a all path, and from that all path we are finding only the list which has
Contain the shortest.
which has shortest segment, then that will also work now.
Yes, sure. If your approach is finding the, if your approach is returning the correct answer, that will also correct. So here, if you are
complexity.
Yeah, if any question, if it is required to complexity things, so definitely you have to retain the efficient solution. If complexity is not required and you think that you can solve that problem using this approach, so that is also correct. Just find out all the path and add all the weights and check which is the smallest.
So why are we adding path.copy, not directly path?
Path.copy, actually here we are just passing this path.value. So sometimes some reference problems we have to face. So for example, we have a one list, okay, L equal to this one list, okay, 1, 2, 3, 4, okay, and we are just assigning this list as a equal to L, and we are changing the A0 equal to 10. Okay, so this update will also reflect into the L, because in that case our L and A are both pointing to the same object. 1, 2, 3, 4. Okay, so if you are updating this A0, so that reflection will also happen in the L, same place. It will also become 10. Okay. So in that case, if you want to copy this type of list or dictionary, so you have to keep in mind so there is a different way to copy. So either you can write like this L like this. You can use this type of copy. Okay, or you can like this L dot copy. These things.
Okay. And so in week 4 PP1, there is a small query like when we are there is a undirected graph, and in undirected graph we have to double the edges. Like for 1, 2 edge there is
which
also
problem you are talking about? PP1 week 4.
Yes, sir.
This is component based. Okay.
Yes, sir. And I have not. I saw this solution after doing my solution. So when I did this, I have not using in addition of the complete edges like it was given in the code of PDSC GitHub IITM. So I was using that approach and adding UE, make a dictionary UE, list UE, in which I am adding E and appending all the other elements to it. Like 1, 2, there is 1, 2 for every ij, append ji also. While I was doing that, I was not able to write UE equals E, and if I append in the UE, it is not appending.
Oh,
but if I write
do you have your code?
Yes, sir.
Can you share it?
Okay, sir.
Share it in the chat box. Persis has said, please tell which algorithm should we do focus for OPP because there are a lot of algorithms and we cannot remember all these. Please help and suggest.
It is not copying from portal.
No, not portal. Chat box. Zoom chat
What's it?
box. Zoom chat. Portal. Okay, okay. No, you can copy. I think copy is working. Control C. So complete code will not copy. I think you have to select the only your code part. Oh, there is no suffix or prefix inside.
Okay, so let me try. Yes, sir. Yeah. Sir, what I have sent here is if
Okay,
I
I'm just okay, 1 second.
I have sent only little part.
Oh,
We have problem.
oh, this is your very small code. Okay.
Yes, sir. I have sent only a small part. In this, while using UE, UE is a undirected edges list of undirected edges.
You cannot tell me now what actually reference you are giving.
Sir, like in the PDSA GitHub IITM page, it was showing this type of code in which we are using making a new list in which we are adding all the edges. Like for we have given edge 1 to 2, we are adding 2 1 edge also.
Okay, okay. That we are doing for the undirected
Yes, sir.
graph.
Yes, sir.
Okay, okay, fine. Yeah.
Sir, so I want to ask why are we doing UE E plus empty list? I have tried UE equals E only that is and appending to UE, but it is not working. But if I use empty list here, it is working.
1 second. So here,
If you remove from here empty list and only UE equals E, then append in UE, it will not work. But if we are adding here an empty list and then appending in UE, it is working.
so what is E here? E is a edge.
It is a list of edges.
List of edges.
Tuple
Yes, sir.
means tuple of edges inside a list.
Okay. So here you are just adding UE equal to E plus empty list. So there is no reflection with. So that means you are just copying the E into UE.
And then we are not. I was not able to append in UE.
No. So this line is not. You can replace this line by using directly UE equal to E.
Yes, sir. I was trying that, but that is not working.
Okay. UE equal to E plus. So first thing I have to check what does the value comes. So for example, if you have a list, so E equal to 1, 2, 3, list of edges. Okay. So our edge, I think, in this form. Okay, so I'm taking this example, and what you are doing, you are just adding UE equal to E plus this. Okay, so what is print UE? This is same. So what error is coming? Can you send your complete code? Then I will check what is running or what is not running, and what is the region, what is the exact region.
Sir, if we remove from the E, in this case also, if we remove, we are appending in UE, and if we remove this empty list and then appending is not working.
Okay, this part. Okay.
Yes, sir. This part I have sent. In this part, if we are appending just in UE equals E, and we are appending in UE, then that is not working.
One second. So you are saying this A list, the list.
If we remove this empty list which you have added here, UE equals E plus empty list, and then append will not work.
1 second. You are saying that if we are writing like this, then append will not work.
Yes, sir.
Okay. Okay. So here E is our list. Removing that part. So J, I comma J in E. You are copying from E here, and here you are okay. UE dot. Okay, 1 second. So same things actually happening because you are just copying UE equal to this E. So that is reflecting to the same object. What you are doing actually here you are, if you are writing this UE equal to E. So what happening? You are just pointing out to the same object. If E, if our list 1, 2, 3, and you are writing like this UE equal to E, that means you are just pointing out this the same object E. 1,
Sir,
2, 3.
It should append. Why it is not appending?
No. So if you are appending, that means you are changing the same object which you are reading in your code. So here you are reading the value from the same object E.
Yes,
And
sir.
you are appending the same object at that same time you are appending the value in the same object.
Yes, sir.
Okay, so we can take simple example. If I'm not taking this things, just remove all the part. Getting your point. So that means you are changing this your data structure which you are reading in your code. So here I'm just passing this 1 comma. Okay, and just saying that this reading from I and just pass. You are doing this now. So what is coming?
It was showing time limit exceeded.
Yeah, that is same. This is because you are adding the same and you are reading the same things.
Okay.
Okay, so if you are reading 1, then you are appending the 1 again. So that means your actual E is increasing every time 1 position. So that will not complete. Your this reading things will not complete.
Okay, sir.
Okay, so here if you are writing this, so it is creating a separate list.
Okay, sir.
If you are using this, that means UE is creating a separate list, and at that time you are reading the element from the E, and this UE is the separate list, and you are appending the element in this UE.
Okay, sir.
Okay, so because of that, the error is coming.
Sir, in this question, I am having a error called key error 3. Means I have written my own code and I am getting.
Send your code.
Yeah, I'm sending.
Sir, can you tell what will be the complexity level of difficulty level of OPPE on Sunday?
I have already discussed in during the start of the session. I think you not joined that time.
Okay, sir.
Difficulty level will be approx similar to your mock levels.
Okay, sir.
Mock question. Okay, I think you have already solved the mock problems. Have you solved?
No, sir, I did only first.
Mock mock problems have you solved?
No, sir. I will
Oh.
solve now.
Solve it.
Okay, sir.
Abhishek, have you sent?
Yeah, it's already in chat box, sir.
Oh, okay, okay. Seems very small.
So this is most frustrating thing in this portal.
Yeah, team is working on that. They are trying to solve these things. PPA4 1. So during the OPP, just after few minutes, so for example, 2-3 minutes, just click on the test run button. Okay, so you will not lose your code. This is for the safety purpose only. So you are getting this key error and line number 25. Find component undirected graph. When you are coming at this A list, append B. Okay, key error 3. That means the value is coming 3 in the U and it is not available. Okay. A list U. Line bar 25. 25 A list of append. So what you are doing in that part?
So basically, as you suggested, like it won't work. So I created a new list UE, and basically I appended all the edges inside that particular list UE.
Sorry, one second.
Okay.
Yeah.
And then basically I'm trying to form this particular A list dictionary.
Oh, okay. So you are creating adjacency list.
Yeah.
This U is empty for U, comma B in E. Okay, correct. UE dot append B, comma U and UE dot append U, comma B. This is a UE. Okay, U is a list. So both sides you are appending. After that, for I in B, A list I equal to empty. A list of U dot append B. Yes. And in your code, what we are giving this in input problem, this is as 1 3 3 4. Okay, so total number of x6 we are giving, and total of number of vertices we are giving 1 to 8. Okay. So actually you are creating a adjacency list.
Yes,
In your
adjacency
code.
list.
And this is your the creation way.
Because I need to pass it to the BFS. So
I got it. So this V is representing here number of vertices I in V. Okay. a list I equal to empty list you are writing occupying for u comma v in ue you dot append p. Okay, just wait. I'm copying this edge. What function is saying that vertices and edge? So I'm creating a one edge list here. So for example, E equal to this edge. Check that. What are the messages I'm due to be? Insulin object is not listed by NB. Okay, we have to pass this information. So what is V equal to? The question V equal to 8. So this is V and what P is representing vertices. This is a list of vertices and a list of vertices 1, 2, 3, 4, 5, 8. Okay, here the vertices is actually different and you are just reading these vertices using the for loop. Okay, so what happened in your code is here the vertices name is also given, which can be different. So 1, 2, 3, 4, 5, 6, 7, 8. These are the vertices for this graph. Okay, and in your code you are reading this I in V. Okay, so you are reading in Y. Okay, so 0 is.
I'm reading from vertices only, no?
Okay, that is correct. Oh, so vertices is a list of 1, 2, 3, 4, 5, 6, 7, 8. Type error line number 8 for I in B. So we have created a list. B. What's error is coming? V is a list. And U comma B. Okay, so you have used for everyone. Print. Yeah, so this is creating one
That's
thing.
what.
Yeah,
Same
actually,
variable.
you are using the same value here. You are changing this V here inside the loop.
Okay,
because
okay,
of
now
that.
I got it.
Just change the name. Okay. Yeah, so Harshjeet, sir, please tell me again which algorithm should you have to focus on. So graph algorithm you should focus, because one problem will be based on the graph. Apart from that, mm, the basic algorithms is required. Not we are not asking this very big algorithms like all uh, big 7 and 8 we have discussed. Closest path. This type of big algorithm we are not asking. Just learn the graph algorithms, and apart from that, the some basic algorithms, logics, and concept. These things are important.
Sir, what about like will this kind of questions will be asked like we have to implement Dijkstra using heap and something like that?
Heap
Like
and
like like there is no foundation of using the data structure how we will basically implement if you are asking to implement any particular algorithm.
yeah, you can use anything.
Okay, like whatever we know from week 5, and like there are two ways. One is like where we have basically improved the complexity.
Efficiency. Okay, you're talking about this frames or digest algorithm which we have implemented using the heap in the week
Yeah,
6.
yeah. That's what.
Yeah. So this type of no, we are not asking that type of difficulty levels. So we are not checking for the complexity on that level.
Okay.
So okay, so basic algorithm will sufficient.
So like if we have to find the minimal cost spanning tree, so we can use any of the algorithm like Prims or
Yes,
Kruskal.
yes. You can use any. Both return the same answer. Same answer.
Both return the same answer. So like
Yeah.
doing one will be sufficient, right?
Yes. So, for example, in the quiz papers, so intern papers or any quiz, so if we are asking the spanning tree value for any graph, so you can apply simple Kruskal algorithm, because Kruskal algorithm you can apply easily during the paper manually. I'm talking about for the manual things, not the
Yeah.
coding part. Manually, you can apply a Kruskal algorithm easy. Just mark the all edge and just sort all the edge, and check that which edge are coming in the spanning tree or not, and which are creating a cycle. Otherwise, if you will implement the Prim's algorithm manually, that it will take lots of time. So,
But coding wise, in which we are comfortable, we can apply anyone.
yes, coding wise, if you are feeling that Prim's algorithm is easy to implement, you can apply the Prim's.
Fine.
So, Harjit, should we focus on up to week 6? That things I cannot confirm. So, you should learn complete syllabus things. Okay, so we cannot restrict to you till week 6. Person can we come from any part.
Hello, sir.
Yes, Harshit.
Sir,
Yeah, Harshit.
actually, there are so many algorithms, na, sir. That's why I'm asking.
Yeah, so there are so many algorithms, and you have completed these algorithms in the 12 weeks. So if you are trying to learn all these algorithms in a one day, that is not possible.
No, sir. Actually, I know all the algorithm, but
Uh,
when I try to implement it in code, it get I got a stuck.
okay, that things I'm saying that no, if you are trying to complete all the algorithms in a one day, that is not possible. So implementation is also not possible. So just learn the concept. We are not asking the every algorithm. So I've already said that week 4 and 5 graph algorithm are important. So there is one, definitely there will one person will be based on the graphs algorithms. Apart
Okay.
from that, the question will be based on the concepts, not for the specific algorithm.
Okay,
So
okay,
for
sir.
example,
Thank
if
you.
we are asking the greedy approach,
Mm-hmm.
so we will not ask the code which you have like the like which Hoffman algorithm. We are not asking that type of code. Okay, so greedy approach based question can be anything where you have to find out the logic.
Okay, okay.
That's things.
And what about the termed exam? I mean, the
Enter
questions
exam
is
we will conduct 3 live session in the next week.
okay.
Okay, so we will discuss topic. We will revise all the topics and question. You can ask the question in that session.
Okay, okay, sir. Is there any mock available for that termed?
Hey, you have already given 2 quiz. Still,
Yes, I know, sir.
yeah,
I
still
know
you have required mock. What is the meaning of mock?
for week 9 to 12.
9 to 12. Okay, 9 to 12 questions are. So I think lots of I think previous term papers are openly available.
Okay, 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 sir. I will.
Okay, just check that you will get the exact papers of the previous term. You can find out the questions
Okay,
of
okay,
the last weeks also, or we will discuss in the revision session.
okay, sir. Thank you so much.
Yeah. So don't leave any part for the OPP exam. Okay, so maybe any part can come in the any part can use in the any solve use during solving the problems. Any concept can be useful to solve the problem. Okay. Okay, any other query? Akash, Abhishek, Harshit, Pranam, Sanjeev, Bimlesh. Any specific doubt in any problem? Any question regarding OPP and others? So this is the suggestion for all. So just appeared in the OPP exam. Don't leave it, because we know that this is not a mandatory thing. You can pass this subject without taking this programming exam, but this is not a good thing. Appeared it. Try to solve with your full effort, and question level is not too much difficult. You can solve it. So everyone should appear in the OPP exam also.
Yes, so we will definitely.
Okay, good. Okay, if you don't have any query, then we can wind up the session. Harshit, Pranam, Sanjeev, Imlesh. Solve all the mock problems. So mock level is the same, similar as a OPP level. Okay, fine.
So can you discuss the problem number 4 of mock?
Okay, that is the also a dynamic based problem. Have you watched the mock session in the previous week Wednesday session?
No, I have not attended. If you have discussed over there, I will see there.
Yeah, we have discussed all 4 questions.
Okay, then it's fine. And what about, like, you have released two more questions? I have not gone through them. So
yeah, that is actually we are using some research analysis to how to find out the approach, how you are solving that questions. So because of that, we are not releasing the solution for that. That is that question is also at the same level of the normal other sports persons.
Okay.
Okay, so just try to solve according to the instruction which are given in that problem.
Okay, fine.
Yes, Sanjeev, your voice is breaking.
Sir?
Are you? Yes, Sanjeev. Sanjeev, you are
How many questions will be there in the?
OPP.
Yes, sir.
4 question.
Oh,
Four
okay.
problem will be there, and
Only
the marks distribution will be different for each problem. So for one problem is marks is 20, and two problems marks are 25, and one problem marks are 30 according to the difficulty level, and all are mandatory.
okay.
Okay, so in 2 hours we have increased half an hour in this term, so you
Yes.
can solve this.
Okay. Okay. Thank you.
Okay, fine.
Thank you.
Okay. Any other query? Anyone? Okay. Thank you, everyone. Best of luck for the OPP exam.
Thank you.
Thank you, sir.
Okay. Okay. Yes.